Hello and welcome to Yajiro Group Design It Day Automotive. Today's topic is automotive grade MLCC solutions for ECUs. My name is David Adib. I am a senior technical marketing engineer here with Kemet in Florida, and I am your host for today's presentation. Thank you for joining us here today as we discuss automotive grade MLCC solutions for ECUs. The presenter today is Hans Heijnen, account manager and field application engineer for Yajiro, based in the Netherlands. Before we start our presentation, I have important information for you. The duration of this session is 30 minutes and has been pre-recorded. If you have questions on anything you see, we want to hear from you. Please go to go.kemet.com/DID-contact. Please, if possible, note the slide number to which your question is related. We will follow up with your question directly after the event is over. Lastly, once Design It Day is over, you will receive via email a short survey. Your feedback helps us to improve our future events. With this information, I hand it over to Hans. Hello, Hans. Thank you for your time today. Please tell us a little bit about yourself and then begin your presentation. Thank you.
Yeah, David, thank you very much. Dear participants, once again, welcome in this Yajiro Group Design It Day. And as already said, my name is, by David, my name is Hans Heijnen. And I am working 43 years for the Philips Vicomp and Yajiro company, of which 6 years in research labs of Philips, then in MLCC ceramic powder development in Philips Passives, 8 years quality.
Hey Hans, can I pause you for a second?
Yes.
I'm sorry, before you start.
Dear participants, once again, welcome to this Yajiro Group Design It Day. And as already said by David, my name is Hans Heijnen, and I'm 43 years in Philips, Vicomp and Yajiro, of which 6 years in Philips Research, and then already moved to Philips Passive Components, where I did 7 years powder development for MLCCs, 8 years quality engineering and quality management, and 14 years MLCC technical and commercial marketing for MLCC. For the next 4 years, I did marketing and FAE for all Yajiro products, and for the last 5 years, I switched to OEM sales and FAE support for my commercial colleagues. So I will first give you an introduction a short introduction for Yajiro. Yajiro Corporation was founded in 1977, and after the acquisition of Philips SMD Passives in 2000, and more recently Pulse Electronics and Kemet, we have become today a real powerhouse as a world-class provider of passives. In addition to the SMD resistors, Yajiro also provides solutions in circuit protection with TVS diodes, metal oxide varistors, ESD arrays, but also in capacitors with technologies ranging from ECAP over film caps, tantalum polymers, and tantalum to supercaps, and last but not least, MLCCs. Next to these, there are more products like inductors, sensors, and antennas, which you can find on your website. Compared to the other electronic applications, the requirements of the automotive industry are stricter, especially for aspects such as high reliability, compatibility with high temperatures, ESD compatibility, high humidity, and resistance against thermal and mechanical stresses. The Yajiro MLCC products for the automotive industry are designed to fulfill customer expectations and demonstrate Yajiro's commitment to this fast-growing area of the electronics industry. In this slide, I will give you a short market overview for MLCC. Yajiro Group now is ranked number 3 with 15% market share, behind Samco with 19% and Murata with 31%. Tayo is close, but the gap to the other ones like TDK and AVX with each 3% is big. Then we have 16% for a number of companies like Fichet, Wolchin, Holy Stone, Fengua, and some others. Yajiro as a group is committed to improve our ranking in the next coming years. Here you see the Yajiro MLCC factories in Asia. We have a backend factory in Dongguan, China, which only does the taping with the components produced in Suzhou, China, or in Kaohsiung, Taiwan. Then we have 2 front-end factories based in Suzhou, not that far from Shanghai, and in Kaohsiung, southern Taiwan. In Suzhou, we mostly produce the commodity, whereas in Kaohsiung, the specials are being produced and also the automotive components. All factories have the ISO certificates, 9000 and 9000 and 14001, OSAS 18001, and Suzhou also has the automotive DS 16949 certification. In Kaohsiung, Taiwan, we also have the more modern IETF 16949 certification received in 2016. And here is the automotive production of Yajiro concentrated. At this moment, we are building a new factory in Kaohsiung, which will be coming on stream in 2022, and in which high caps and more high caps and automotive products will be produced. And this will further boost the Yajiro global capacity. MLCC trends in sizes. The global trend is to ever smaller sizes, as visible in this chart, covering 17 years. At this moment, 0402 still dominates, but with the growth of mobile devices and pressure on size, 0201 will take over, as is expected, the 0402 position in 23-24. The 0105 shows a bit more moderate growth, but this might accelerate in future. And for the bigger sizes at the bottom of the slide, we see a stable or declining development in relative volume, but these will not disappear because they are further needed for high voltage and high caps. The Yajiro capacity plan for the last few years has seen a strong increase in volumes we can produce. The total volume per month was 45 billion pieces per month, growing to expected 88 billion pieces per month in 2021. And this is the Yajiro plus Kemet production capacity. The major capacity is in the smaller sizes, as you can see, 0201 and 0402, which have about 50% of the total capacity we manufacture. The second biggest capacity is for high cap, almost 20%. However, the fastest growing area is the automotive grade AC, AS, and AQ ranges. In 4 years, an 8-fold increase from 1 billion pieces to 8 billion pieces has been realized. For sure, beyond 21, we will further invest and expand our capacity. Now we have a deeper look in the automotive area. The number of functions is increasing rapidly for all applications. Translated to components per car for internal combustion, EHV, PHV, as well as for EVs, the compound annual growth rate for MLCCs is above 15%, not only for powertrain, but also for infotainment, body control, comfort, safety, and battery management, and the fast-growing advanced driver assistance systems, ADAS. The vehicle production is expected to grow from 96 million units in 2018 to 130 million units in 2024, resulting in an MLCC consumption growth from 440 billion pieces per year to over 1,000 billion pieces per year in 2024. In parallel, there's a shift from commodities to much more advanced high caps and high voltage parts, especially in EHV, PHEV, and fully electrical vehicles. Let's have a look at the BOM usage for MLCC in the car. On the left, the growth is reflected in the numbers per functional area. Body control, about 1,600 pieces per unit, via 2,400 pieces in ADAS, and in engine control to 3,200 pieces for electronic power steering. We arrive at an unprecedented number of almost 14,000 pieces MLCCs per car. In the right part, we see the increase from IC to full EV, from almost 3,100 pieces per car to 8,000 pieces for PHEV to 15,000 pieces for full electrical cars. Clear is that the growth for powertrain is in EV is fastest, a 15 times increase, whereas for non-powertrain in EV, the increase is 3.5 times relative to the IC cars, or conventional cars. Related to this, we can identify a number of design trends in MLCC used for these applications. The shift to smaller sizes is ongoing rapidly. Yajiro offers here the AC0402 and AC0201 automotive grade ranges, higher temperatures, 150 degrees. Here we offer the X8R and XAG ranges, increase of resistance against thermal and mechanical stress, the ranges with SoftDomination AS, and the quickly increasing wireless and antenna applications for which we offer the low JOJO AQ Series. I come back to these in more detail later. Have a look at the engine control units and MLCC. This slide gives an example of an engine control unit and the various functions it has to cover: engine temperature, turbo pressure, fuel injection, controlling knock, ignition and injection time, and the particulate filter control system. Within these functions, the ECU has to deal with many sensor inputs, has to control them and feed back the proper instructions for the related devices. A very complex operation which requires a lot of software functioning under harsh conditions like high temperature, heavy vibrations, electrical interference, etc. In order to guarantee a long operation time with no failures, the quality, reliability, and functioning of the components has to be excellent. Yajiro automotive grade MLCCs cover these requirements. Here we see the block diagram of the engine control unit. In the center, the microcontroller and the inputs and outputs for the different functions. The sensor, the buses, peripherals and motors have to be steered by the controller. And to guarantee a proper functioning at high speed, all kinds of MLCCs are needed in the various circuits around the microcontroller. As we can see here in an example of a DC converter. Two high caps are already visible 2 times 100 microfarad with a voltage of 10 volt, used for filtering in the output circuit. For the input circuit, we have 2 times 10 microfarad capacitors, MLCCs, for decoupling. Then we have here another high cap and a few low capacitance values, 1 nanofarad and 22 picofarad. Already here in the simple circuit, we see a variety of MLCCs from low capacitance value to very high capacitance value. We will have a further look of the Yajiro offerings for these components. Now we have a look at the Yajiro automotive ranges and the related technology. Trends in automotive already mentioned a bit before. Reliability improvement. The numbers of MLCCs on a board in automotive applications are quickly increasing. To avoid any increase of the risk of failures of the ECUs, the reliability per part has to be increased, or in other words, they should show lower fit rates. Here we offer the JOJO AQ Series. Operating temperatures transfer to higher temperatures in applications. Hence, the temperature range has to be extended from currently 1 to 5 for most components to 150 degrees, and in future even higher, 175 or even 200 degrees centigrade. The Yajiro XAG and XAG series are operable until 150 degrees. More and more wireless high-frequency applications are installed in the car, like infotainment, car-to-car communication, a tire pressure measurement system, etc. Here, Yajiro offers the high-frequency AQ series. And last but not least, improvement of mechanical and thermal strength. As the number of MLCCs in the applications is increasing, the failures induced by mechanical and or thermal stresses should be mitigated. Here, Yajiro developed the AS series with soft terminations. In the following slides, I give some more details about the automotive grade ranges. The AC series is the standard range in discretes and arrays. So case sizes are from 0201 to 1812, and for the array 0508 to 0612 size. The rated voltages range from 6.3 to 1 kV, and the capacitance range from 0.47 picofarad to max 10 microfarad. Temperature characteristics are NP0 X7R up to 125 degrees centigrade, and the X8R XAG usable up to 150 degrees centigrade. Here we see the comparison between NP0 and XAG, where NP0 is usable up to 125 and XAG up to 150. NP0 is defined as negative positive zero. It means that the max capacitance deviation over the temperature range is very limited, close to zero, and specified at 30 plus minus 30 ppm per degree centigrade. The deviation has to stay within the red lines. Reality is better than the maximum allowed deviations, as you can see here from a measured graph. Moreover, the deviation is relatively linear and can be used when designing the circuit and the prediction of the capacitance deviation with temperature is needed. As temperatures are increasing, there is a need for a higher operating temperature up to 155 degrees. And it's defined as XAG, with the same TCC as the NP0 working until 125 degrees. So also linear within the plus or minus 30 ppm per degree centigrade. Yajiro's XAG fulfills this requirement. Similar upgrading for X7R is available. The requirement for the capacitance deviation for the standard X7R over the temperature range -55 to 125 has to be within plus minus 15%. Upgrading to 150 degrees, the X8R spec demands the same plus or minus 15% variation, as is shown here. To achieve this, the ceramic used for X7R has to be modified such that it is harnessed until 150 degrees and fulfills the plus minus 15% requirement. This is much more difficult than for NP0. It only can be realized by sacrificing the dielectric constant with, as a result, lower max gap values for the same size and rated voltage. A typical dielectric constant for X7R is between 3,500 and 4,000, while for X8R, it is roughly between 2,000 and 2,500. When going to the DC bias behavior of the X7R and X8R, it seems that the X8R is better than the X7R for the same component, weight 5, 50 volt, 100 nanofarad. The drop of capacitance value at 50 volt DC for the X7R is roughly 45%, whereas for the X8R, the drop is only 22%. However, this is purely the result of the lower dielectric constant we discussed on the previous page, and not an improvement as such. High frequency MLCCs, the JOJO AQ Series. In order to have a better performance in HF behavior, the metal used for the inner electrodes is changed in this series from nickel into copper. Copper has a much better specific conductivity compared to nickel, about 6 times lower. This means that the high frequency losses, ESR, are much lower for MLCCs with copper inner electrodes. So these copper high frequency ranges are better suitable in today's applications. The sizes range from 0201 to 0603, voltages up to 250 volt, and capacitance range from 0.2 picofarad at the very low end to 100 picofarad as max value. This slide shows a comparison between the standard 0603 NP0 50 volt 10 picofarad with the nickel inner electrode and the AQ series with the copper inner electrode. At 3 gigahertz, the ESR for the standard nickel one is about 400 milliohms, whereas the copper component, the component with copper inner electrodes, has an ESR of at the same frequency at roughly 200 milliohm. So a big decrease to limit the losses at the higher frequencies. With this AQ range, Yajiro is very successful in the quickly growing high-frequency car applications. Then we arrive at the last part of this presentation, the MLCCs with the capability to mitigate the effects of mechanical, bending, vibration, and thermal cycling stresses inside the car. It's the AS with the S from SoftDomination Series. We produce it in 0603 to 1210, up to 250 volt, and with capacitance ranges 1 nanofarad to max 4.7 microfarad with X7R as the ceramic. Larger sizes are not preferred in automotive, so we don't extend it to 1812. And the other side, smaller sizes are, for smaller sizes like 0402 and 0201, the impact of these stresses can be neglected in the sense that they do not easily lead to damaging of the component. We can compare some 4 types of construction in MLCC when we talk about cracking and crack prevention. Standard design, open mode design, floating electrode, and here the soft termination. When we look to the bending levels for the standard one, it merely is 1 millimeter, maybe a little bit more. Open mode is the same. Floating electrode is the same, only soft termination shows an increase of the bend strength of 3 millimeters and higher. Now, in all cases, the failure mode can be a crack in the ceramic, as we can see here. The standard mode, the standard construction, standard design, does not have any prevention against cracks, and the crack will cross several electrodes, and with the penetration of moisture in the ceramic body, we will have a perfect short circuit from right to left in this case. When we go to open mode, this has been mitigated by increasing the distance between the electrode and the termination. So if a crack is introduced, then it will not cross electrodes like here of opposite polarity. For floating electrodes, the solution is to place a floating electrode between the other electrodes. And if a crack now is introduced, it crosses several electrodes, but if there is a conduction due to penetration of moisture, the electrons go no further. They stop here, so they never reach this site. So no short is possible. For soft termination, it's different. We apply an extra polymer layer, which absorbs the thermal or mechanical stresses to a high extent. And if a crack occurs, it's in opening the termination. So it causes a drop of capacitance. And in the next slide, I will give, so excuse me, the Yajiro solution to mitigate the effect of cracks is the soft terminations we applied. And in the next slide, I will give some advantages and disadvantages of soft terminations. In this drawing, we see at the left side the standard design. And if a crack is introduced, either mechanical or standard, it crosses several electrodes. By the penetration of moisture, we have a hard short circuit in the end. Same here, electrons flow from this side via the crack to this side and give a short circuit. To prevent this, you apply an extra layer, the red one here, which is a combination of an epoxy resin and silver particles dispersed in it. This epoxy layer absorbs to a high extent the mechanical and thermal stresses applied on the component in the application. And with this solution, you achieve a very high bend strength with sometimes over 5 millimeters, for instance, for a 1206 component. Okay. Of course, the soft termination not only has advantages, there are also some disadvantages. Let's have a look first at pros. Concept is adding an extra layer of silver particles dispersed in an epoxy polymer, and this epoxy layer acts as an absorber of mechanical and thermal forces. It shifts the band cracks from 1-2 millimeters to larger than 5 millimeters deflection. It allows much more than 1,000 thermal cycles before cracks occur. However, due to the application of an extra layer, the ceramic brick has to be designed a little bit smaller to stay within the international specifications concerning the dimension of the component. So this leads to a minor loss of capacitance of the top value. The second effect is the cost increase, cost of the epoxy silver material, the 2 extra process steps like dipping of the and application of the epoxy silver layer and curing of the epoxy resin. But the advantages are far more than these disadvantages. And with the previous slide, I come to the conclusions of this MLCC presentation. Requirements on performance of MLCCs in automotive are quickly increasing. Improved reliability, increase of operating temperatures, increase of frequencies, better performance against mechanical and thermal stresses. For this, Yajiro offers the AC series, the XAG and XAG ceramics, the EQ series, and the AS series. So we provide a comprehensive product portfolio to cover the requirements above. And further, Yajiro is committed to investing in production and innovation to serve the rapidly expanding automotive markets by extending the production capacity, by expanding the current ranges with higher cap values, higher voltages, better HF performance, better performance under mechanical and thermal stresses, continuous enhancement of the reliability of the total portfolio, and developing new ranges and extending existing ranges for use with higher operating temperatures. And by this, I would like to thank you for your attendance. If there are questions, feel free to contact us. I wish you a nice day. Thank you.
Thank you, Hans, for this presentation.
Welcome.
And once again, ladies and gentlemen, thank you for joining us today in this recorded session. Until next time, we wish you the best. Have a good day and goodbye.